Next, I'll explain inverse maps. But before that, we first define the notions of injection and surjection and bijection. Okay, let's say we have a map from X to Y. Then this F is called injective or one-to-one. If the following holds, that is, if x and x prime in X, if they are different, then f of x is different from f of x prime. So if this holds for every pair of elements in X, then we say this map F is injective or one-to-one. So what this means is this. F is a map from X to Y, right? So if we pick two different elements in X, then they will never map to the same element in Y. So X and X prime. So this doesn't happen, okay? This will never happen for an injective map. So that means if two elements are different, they map to different elements in Y. So that's what injection means. And next, I'll explain what surjection means. And again, we have a map of F from X to Y. And we say F is surjective or onto if the following holds. For every element in Y, there exists some element in X such that Y is equal to f of x. So what does this mean? In a general map, it can be like, so we have X and Y. So for every element in X, we have some correspondent element in Y, right? But that does not mean that every element in Y has its counterpart in X. So what this means is that the image or the range of F is a proper subset of Y. So in that case, the image is a proper subset of Y. So there are some part in Y that has no corresponding elements in X in general, right? But for surjective map or onto map, this doesn't happen. So every element in Y had some counterpart in X such that that counterpart in X maps to that element in Y. So the entire Y is covered, so to speak, by this map from X. That is surjective or onto map. So a map can be injective or surjective or both injective and surjective. Okay? So injection and surjection, they are not mutually exclusive concepts. They can coexist. So if a map is both injective and so at the same time, if it is surjective, then we say the map is bijective. So what this means is that for every element, since it's surjective, for every element in Y, there exists some X in X such that Y is equal to f of x. But since it is also injective, that means this X is unique. So uniqueness. So in general, for a surjective map, this X can be, there can be multiple X's that correspond to this Y, right? But since it's injective, this X is unique. There is only one x exists in x such that y equal to f of x holds. So that's what bijective means. In general, for any map from x to y, if we pick one element in x, the image of this x is uniquely determined in y, right? So it cannot be like bifurcation like this. So this is not a map at all to begin with. So this cannot happen. And in a map, if we pick one element in x in the domain, then there is unique element in y determined by this map F. So for a bijective map, for every element in y, we have a unique element in x, right? So actually that determines a new map from y to x. So if we pick any element in y, there is a unique element in x. So that map, new map from y to x, is called the inverse map or just inverse of f. And this map is called f inverse, f to the power of -1. So by appearance it looks like that, but it's called f inverse. So for a bijective map, if y is equal to f of x, then x is equal to f inverse of y, and vice versa. And vice versa means, what is the inverse map of f inverse? F inverse is actually equal to f itself, right? If this holds, then this holds. If this holds, then this holds. So that means f inverse is also bijective. So there should be the inverse of f inverse, and that is actually equal to the original map f. And this map is, if it is a linear transformation, if this is a linear transformation, let's say in two-dimensional space, then there is some matrix that represents this linear transformation, right? And if this f is this map is bijective, then there exists f inverse. And actually, in this case, there corresponds a matrix called A inverse. So f and f inverse are represented by the matrices A and A inverse. So if x prime y prime is equal to A xy, then using A inverse we can write xy is equal to A inverse and x prime y prime, right? So just like this, we have something like this. So that means if we apply, so let's see, let's put this one into here. Then we have xy, A inverse, A xy, and A inverse, A xy. So this xy, this matrix xy, this is actually a vector, but it's also a matrix, is transformed to itself. So that means this matrix should be equal to the identity matrix because it doesn't change this x and y. So A inverse times A is equal to the identity matrix. In two dimension, we have 1, 0, 0, 1. That's the identity matrix. Okay, that's all for this video. See you later. Bye. Thanks for watching. If you like this video, please hit the like button and subscribe to this channel. See you next time. Bye.